हेलो दोस्तों, मैं अशोक तिवारी आपका दोस्त। आप सभी का अशोक तिवारी के इस चैनल पर स्वागत करते हैं। दोस्तों, आज मैं आप लोगों को इनवाइट करना चाहता हूं, जो भी लोग साइंस पढ़ना चाहते हैं, सो दे स्टार्ट ज्वाइन आवर टीम बाय द कमेंट बॉक्स, राइट योर व्हाट्सएप नंबर्स एंड द क्लास एंड फ्रॉम वेयर यू आर जस्ट connected. Everything you write it here. Students, in this channels, we are just providing you the tutoring for the mathematics, science, and their sample problems, step-by-step solution, communication in English. Get the high grade. Even we are using sometimes the Hindi language also to understand. Those students are not compatible in English, they can easily understand the Hindi also, and they can clear their concept. So don't delay, just join our team, science. So today, students, we are just coming with the topic, that is the gravitation. All the concepts and the formula we will discuss in this lesson. स्टूडेंट्स, आज हम लोग ग्रेविटेशन के कॉन्सेप्ट्स एंड फार्मूला के बारे में पढ़ेंगे। ग्रेविटेशन, जैसा कि हम जानते हैं, दैट इज द जॉनसन कैप्लस एंड द सर आइजक न्यूटन। द नेम वाज फेमस and they have done lot of work into these chapters. In these chapters have these lot of properties: gravitation, force of gravity, Newton's universal law of gravitation, properties of gravitation force, universal gravitation constant, Kepler's law of planetary motion, Newton's second and third law in gravitation, what is free fall, acceleration due to gravity, equation of the vertical motion, mass and weight, thrust and pressure in the fluids by these things. So students, the gravitation force of this, that force is necessary to produce motion in the body. So the body drop from the height, suppose कहीं ऊंचे स्थान से आप कोई चीज गिरा रहे हैं, are dropped from the height, fall towards the earth. It indicates that the earth exerts a force of that attraction, that is called gravity on that body. So in fact, students, the earth attracts all the objects towards its center. It means the force which the earth pulls the object towards it, it is called the gravitational force of the earth, or that we are telling it is the gravity. So the gravitational force between the sun and the earth, that keeps the earth in the uniform circular motion around the sun, students. So this is the gravitational force of the earth, or that is due to the gravity. If I talk about the gravitational force of the earth or the gravity, so what is the responsibles, and this is responsible for holding the atmosphere above the earth. तो जो भी आप अर्थ के ऊपर में एटमॉस्फेयर देख रहे हैं, वो कैसे होल्ड किया हुआ है? ड्यू टू द ग्रेविटेशनल फोर्स. फॉर द रेन फॉलिंग ऑन द अर्थ, जो रेन ऊपर से नीचे की ओर गिर रही है, दैट इज द रेन फॉलिंग ऑन द अर्थ, दैट इज ड्यू टू द ग्रेविटेशनल फोर्स ओनली. The flow of water in the river, so that is also due to the gravitational force, and keeping us firmly on the earth, that means easily we are able to move on the earth, that is due to the gravitation only. And for the revolution of the moon around the earth, that is due to the gravitation. So gravitational force is equal to capital G, capital M, small m by r square. Students, that is the gravitational force, capital F. Here is the two masses, the one is capital M and one is the small m. In between both the sides, because of that both are just applying the force, and the distance between the two masses are, that is here d. So capital G is the universal gravitational constant, and the d is the distance between the capital M and m, is the two object is here. So the formula is here, capital F is equal to capital G, capital M, small m by d square. So this one. Students, one more important thing, that is the Kepler's law. Kepler's law, whenever I am talking about that, the law of orbits means all the planets moves in the ellipsis orbitals. तो स्पेस में जितनी भी आपकी प्लैनेट्स हैं, वो सन के चारों ओर जो मूव कर रही है, दैट इज मूविंग इनटू द एलिप्टिकल ऑर्बिट विद द सन सिचुएटेड एट द वन ऑफ द फोकी ऑफ द ellipsis. Since if I am talking about the law of area, the line that join any planet to the sun sweep equal area in the equal interval of time. Suppose here is the sun, and from this sun, suppose this is the A is a planet, it moves from the A to B. So it cover, that is the sweep. So this area, suppose I take the another planet, means this planet has reached here the C to D. C to D, that area. So this area and this area, that sweep equal area in the equal interval of time, means whatever the time is taking here, that time will take here also. So this is the law of area. Law of period. The square of the time period of revolution of planet is proportional to the cube of semi-major axis of the ellipses traced out by the planets. So student, this is the third law of the Kepler's. So t square by t square by r cube is equal to the constant for all the planets that is orbiting the same central body. Let's take the universal law of gravitation as we have discussed. That suppose the two masses, the m1 and m2. The m2 is applying the force here. That m1 is also that r cap 21 and here that f21 vector. So f21 vector is equal to z m1 m2 by r square. That also we can write if it is applying the force in the opposite direction. So that f21 vector is equal to minus capital G small m1 m2 by r square. So r cap 21 we can write the r21 vector by r. This way also we can write into this. And the f21 vector is equal to minus g m1 m2 by r cube, that is the r vector 21. So this is the universal law of gravitation we can write in the three way, right? Important results of for a shell, if I am talking about that, suppose you are having this we know the force of attraction between the hollow spherical shell of uniform density and a point mass situated outside is just as if the entire masses of the shell is concentrated at the center of the object. Suppose that m1 is here and the m2 is here. So the m2 is applying the force, that we are writing the f21 vector is equal to z m1 m2 by d square. And here the m1 is just suppose that imagine that f1 is the center, so it is just if the entire mass of the cell is concentrating at the center of the cell. But if you are putting the another object inside of that, so that what happen, the small thing, the force of attraction due to the hollow spherical shell of uniformly density on the point mass situated inside, if anything is situated inside, that will be neglected and that will become a zero. So this is the important result for the cell. So that final formula we will write f21 vector is equal to z m1 m2 by d square. Students, acceleration due to gravity. Acceleration due to the gravity at the surface, we are knowing that a small g is equal to 9.8 meter per second square. So the formula will be the small g is equal to capital G mass on earth divided by the that is the radius on earth square, or the distance of the earth square. For second, if at a height above the surface of the earth, means that above the surface of the earth if I am taking, so that formula is g dash is equal to z 1 plus h upon r a whole minus 2. Or if the height is less than this r a, then we are approximate formula we are writing g dash is equal to z, and this 2 will come in front. So the minus 2h by r e. So this is the approximate formula, but the actual formula is this one. So actual formula is this. This is the approx formula if this is less than this one. So this is one formula. At the depth means that d below the surface of the earth. In that case, we are writing the z cap double quotes is equal to z 1 minus d by r e. So this is the acceleration due to gravity. In these three ways, we are going to be find it out. Gravitational potential energy, if I am talking student, that is called GPE, associated with the two particles of the masses, then we are just writing U is equal to minus G capital G m1 m2 by r. That r is the distance. Suppose the gravitational potential energy is associated with a system, suppose m1, m2, m3. So m1 to m2 is having some distance, that is the r12, and m2 to m3 is having some distance, that is the r23, and the m3 to m1 is having some distance, that is the r13. So we are writing the gravitational potential energy, that is the minus g m1 m2 upon r12 and this plus. So this three way z m1 m3 by r13, z m2 m3 by r23. So this we are going to add and finding the gravitational potential energy, students. Escape velocity, students, that is the k potential energy, that is the ke is equal to plus capital G m e small m by r e, so that we are writing the V is equal to root 2 capital G m e by r e is equal to that we can write the root 2 z r. Satellite motion, students, you see that is the RE, and from here that is the radius, and orbit means that we are just going to identify their path, that orbit. So here we are writing the satellite motion because you know on the earth, surrounding the earth, the satellite is moving like the natural satellite moon is moving. So we are writing the potential energy. Kinetic energy is equal to plus G m e m by 2 r orbit. Okay. So that potential energy is equal to plus G m e m by 2 r e plus h if it is on the earth. Potential energy is equal to that we are writing minus G m e m by r orbit. So the potential energy is equal to minus G m e small m by r e plus h. Total energy is equal to minus G m e m by 2 r orbit. So the total energy is equal to minus capital G capital M e m by 2 r e plus h. So this is the satellite motion that you can understand that. So the gravitational force between the earth and the moon causes tide in the sea. So that you know that is the sea. So in the sea the tide is coming. Students, the few facts about the lunar tides you are very much familiar, so I am not going to discuss Newton's universal law. So if the force of attraction is directly proportional to the product of their masses, so the F is proportional to m1 into m2. If the force of attraction is inversely proportional to the square of the distance, then F is inversely proportional 1 by r square. So this is the m1 and m2 masses. So these two bodies A and B masses m1 and m2 are placed at the distance of r from S. So these two formula you are having. So F is proportional to m1 and m2 by r square. So the F is equal to Z m1 into m2 by r square. G is the constant that is called universal constant. Universal gravitational constant that capital G is equal to capital F r square by m1 into m2. So capital G is having the value 6.67 into 10 to the power minus 11. So this is the value. So all of you have to be careful. And if I talk about that first law of orbit, so that orbit already we have discussed. So T square upon RQ, that is a constant. So the square of the time period of the revolution of the planet around the sun is directly proportional to the cube of mean distance of planets from the sun. So this is the law of mathematically expression. After that you see, if I are just finding that is the acceleration, the force is equal to mass into acceleration, so F is equal to mb. If A you are just finding that F upon m or F upon m, that you are going to find it out. Free fall, you know that this the experiments, both you are going to fall into the glass, the body fall from the height towards the earth only under the influence of the gravitational force, and the body having a free fall, that is called freely falling body. Imagine that vacuum is created, then that case what happens, the same force is coming but the objects are coming on the same time, but if it is in the presence of air, that time it is just coming in the different time. Acceleration due to gravity, students, the small g is equal to 9.8 or meter per second square, in the centimeter 980 centimeter per square. So we are using here the function if the force exerted by the earth on the body, when question is given the force exerted by the earth on the body, in that time we are using this formula. So capital F is equal to capital G capital M into small m by r square. So this is the earth. On this earth the m mass is object is just here the central force, and this is the distance and this mass. So the force exerted by the earth produces an acceleration on the bodies. Therefore F is equal to mg, and g is the acceleration due to the gravity, right? So mg is equal to capital G, because of that here capital M into m by r square. Okay. So in the place of F, you are just writing this because of that G value is here. So small g is equal to capital G capital M by r square, because this m and this m is cancelled. So students, you have seen that how the things are just happening here. So mass of the earth is 6 into 10 to the power 24. So mass of the earth is 6 into 10 to the power 24 kg, and the radius of the earth is 6.4 into 10 to the power 6 meter, and gravitational constant is the 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. So small g is equal to capital G capital M by R square. Substituting the value, we get the g is equal to 9.8 meter per second. So here acceleration due to gravity. Here you see this is the g small g is equal to capital G capital M by R square, or the g dash is equal to capital G capital M by R plus H on the earth whole square. Okay, because it is having the some height. So this height we are also going to add. Okay, so this is the complete one, R plus H. So R from here, and then this is from here. Also we are just writing that is H. So R plus H we are just writing. Fine. So acceleration due to the gravity decreases with depth. Here what you have seen, acceleration due to gravity decreases with altitude. If it is altitude decrease, then small g is equal to capital G capital M by R square, or either g dash is equal to capital G capital M by R plus H whole square. If the acceleration due to gravity decreases with depth, means it is coming down. Earlier you have seen it is going up. So that is small g is equal to capital G capital M by R square, and here the g dash is equal to capital G M dash by R minus H whole square. So this, whenever it is coming down, it is negative. Acceleration due to gravity is greater at the pole and less at the equator. Greater on the pole and less at the equator, so that greater on the pole is equal to capital G capital M by Rp square, and that G is equal to Gm by Re square. Earth is slightly flattened at the pole and bulging at the equator. So the radius of the earth at the pole is 21 kilometer, less than that of equator. So in that case, we are just finding this thing. Equation of the vertical motion, students, whenever under the influence of that, equation of the motions are V is equal to U plus GT, H is equal to UT plus half GT square, and V square is equal to U square plus 2GH. And when the bodies drop freely, the equation of the motion are V is equal to GT, H is equal to half GT square, V square is equal to 2GH. When the body is thrown vertically upward, the equation of the motion is, so that is the motion is here, V is equal to U minus GT, H is equal to UT minus half GT square, and V square is equal to U square minus 2GH. So this is basically that is the equation. I hope. Mass of the body is quantity of matter contained on it. Already you are knowing mass is a scalar quantity. Weight is equal to that. Weight is the body on the earth is the force with which it is attracted toward the center of the earth. Means weight is equal to mass into acceleration. Okay, so mass into gravity here. So that is the weight. So you know very well Archimedes and Blaise Pascal. Thrust and pressure, students, whenever I am just going to apply the pressures on the table. So when the blunt pins is the applied force, it does not go into the wood, whereas the sharp pin goes into the wood with the same amount of force. The reason is what? The effect of force depend on the area of object on which it is acting. So weight of the body is also force, always act in the downward direction. So here, students, pressure is equal to force upon area. So P is equal to F upon A. Pressure is a scalar quantity, so the pressure is equal to thrust plus area. So students, this is the observation. Buoyancy force is not in your course. So that are the some question which we have discussed. Density D is equal to M upon V. Density is equal to mass of a substance upon the volume of the substances. The density of substance is one of its characteristic property. So the SI unit of the density is the kilogram per cubic meter, and the CGS density is the gram per cubic centimeter. So relative density of substance is the ratio of the density of that water. So density of the substance upon the density of water. So RD is equal to DS by dW, relative density. Here you can find it out. So that's all, students. If you are having